Hey, good morning, everybody. Welcome to Focus Group 5 of the EMP-E. Sorry for the delay. We're having slight technical problems, as always. One would think that after half a year of online conferences, we had figured it out, but I'm very sorry. We're still working on learning how to make this all work. Nevertheless, we are still trying to get one of our speakers, Suvayu, on the phone so that he can present or he can talk to his slides, give his presentation to the introduction. In the meantime, you should see my screen. We want to start with a Slido presentation, but before we go into the presentation, there is one very important thing that I should tell you, and that is this meeting is being recorded and will be publicly released. This does not really affect you because all the participants will not be able to talk directly, but it might still be that if you type a question in Slido with your name could show up in the screen grab. So be aware of that. The meeting is being recorded, and if you don't want your name to show up by accident somewhere, then don't type any questions with your name in Slido. Or don't write any questions into the GoToWebinar question tool. So we already have 20 answers on our active poll. We wanted to get some overview of what your background is. It seems that most people here are researchers working on the energy system, with a couple of policymakers, a couple of other researchers, and some people working on data management. Okay, let me go to the next question. This focus group is about data exchange, formats, databases, how to link models. So we wanted to get some idea of which data formats you already know. Okay, so most of you are familiar working with Excel. Some of you have worked with the Frictionless data package or the IMC format, and some of you know the Open Energy Platform data model. That is great. That will be a good introduction. Then with Sarah starting her talk in a few minutes on the open data ontology, open energy ontology. Let me quickly continue. One big outcome of today's focus group is where we can do more harmonization across the different tools and packages. So this question is, where do you see the biggest need for us working on harmonized tools? Okay, this is great because we will have two breakout groups, one on data models and I guess definitions of sectors and regions, and another one on data exchange formats, and the third one on and the second one on workflow management. So I guess that the two breakout groups are very much aligned with where you see the biggest need for harmonized tools. Thank you very much. Now the question is not just whether we need more tools, but also which support is most helpful to get new users started working with these tools. And a lot of different research teams try different approaches. The question is what works well, where do you see more need for this kind of work, what is most helpful to get new users of a tool started. Okay, this is super interesting. So it seems written material is what is most useful. Webinars and video recordings also, but not so much. And community engagement like email lists seem to be not that important to the audience participating today in the focus group. And now as a last question, we already asked a similar question of which data models do you know? And now we want to know which ones do you actually already use in your everyday work? Okay, so most of you work with unstructured Excel files. So there is definitely a lot of scope for harmonized tools and common improved data formats, which will hopefully make it easier for collaborating towards model integration. Thank you very much. That was super useful for us to get an understanding of what you see as the needs and what you already know and what you expect from us. So now I will hand over to Sarah to give her 5-minute introduction to the open energy data models, and then we'll hand on to the other speakers. Everybody will give a couple of minutes presentation from their point of view, from the project that they're working on, and then we will proceed to the breakout groups to have a more interactive discussion.
Yes, thank you, Daniel. So I hope that you can see my screen now.
Yes.
So for me, it says it does. So, okay. Yeah, so thanks for giving me the opportunity to speak here. And I'm Sarah Birendes, researcher at the Rhein-Hellemann Institute and the project coordinator of the Open Modix project. And I'm happy to present you the latest developments or results here. And that's yeah, the open OE data model, as we call it, so an open data model for multi-framework simulations. In the Open Modix project, we do framework comparison of 5 open source frameworks, and also they have different programming languages. So what we want to achieve with this data model is that we have efficient and user-friendly data processing, a standardized data format so that easy exchange is like enhanced, so that energy scenario data can be exchanged across different frameworks, and also that the visualization is consistent, and so that modeling results of the different frameworks can be plotted very easily. So why another data model? Of course, we know that there's a lot of data models already established, and we also, I mean, it's not that we build a new model, so we use the previous discussions and we actively taken part in the discussion. So what we have, like for example, in the Open Energy Modeling Initiative, we looked at the IMC template. What we found difficult, for example, is that we don't look at very specific energy system modeling. So we have different, like some frameworks that are more focused on macroeconomic modeling, but all others go more into detail. So we needed an adjustable temporal and spatial resolution that's easy handleable. So, and also we wanted to have like programming language independent connectors. So yeah, now the idea is that we have the database. So where the data is stored, then we build easy usable connectors, and then you can just map your frameworks or different data formats to this connector, and you can easily communicate with the Open Energy platform. So at the moment, the Open Data Model, there are two variations. So there's the Open OE Data Model Concrete. This is more for the user side. It's the main usage is JSON and CSV files. And then there's also the OE Data Model Normalization. This is more like specifically developed for the data management side. So there's even more development going on there. So feel free to contribute there. I want to focus on the OE Data Model Concrete in brief. And definitely I can't say anything, I can't cover everything here in this 5-minute presentation, but basically it's like this, that the data model consists of 3 different table types. So scenario table, scalars, and time series with different fields here. And the relation from the scenario table to scalars and time series table is 1 to n. So you can plug multiple scalars, multiple time series tables to the scenario. And different to the IMC model, we go with hierarchical structures of parameter naming again, because we found it easier with the querying. So that's why and also energy system specific naming here. So input energy vector, output energy vector, technology type, and then you go to the parameter name, or you define the parameter name. And for example, we also have method field, so that you can specify if a value is an aggregation or something like this, or that you use a sum or a median of different values, and also a source field so that you can reference also single values and time series. Yeah, so workflow download, like what we do, how is it working now? So at the moment we're developing the OE Data Model API to download data from the OEP and communicate with it. So at the moment, this is I put some examples here. So it's browser-based querying. At the moment, it's functional. It doesn't look very nice, so what you can do there is you can just vary the URL, you can communicate at the scenario ID or name, you can communicate with the Open Energy platform, and you can add different mappings. So what we use is GemusPath at the moment, because with GemusPath, so you'd query from the Open Energy platform, you would query your data as JSON, as a raw data, a JSON raw data file. And then with the mappings, you can query from that JSON file into your specific framework. So you can just plug your specific mapping to that. Please, if you're more interested in that, have a look at the GitHub repository. You find some example mappings there. And then you can easily download your scenario data as CSV table or JSON, and the way you want to. And with that, so yeah, the upload is at the moment not working like this. It's more like you bring the data into the OE Data Model Concrete format, you fill in the metadata string, then you put a pull request onto GitHub, and then after it's reviewed, you upload to OEP. But the idea behind this is that you can store energy scenario input data and results in the same database also. Because we also want to look at interfaces, and that's what we're most interested in actually here is also, so we are, for our model comparison, we also compare the results, and therefore we know like that there are great functionalities, plotting functionalities available, for example, in PyM. We would very much like to use this tool, and we're just checking if that's possible. But what we, at the moment, we are very positive that we can like easily build a connector also like with this mapping function. We can easily build a mapper from the OE data model to the IMC model. And then with that, we can use the PyM plotting functionalities. So that's what we check at the moment and plan and hope to do. And that would also mean that whenever we contribute also plotting functionality specific to the OE data model with that connector, like with that mapping to between IAMC data model to OE data model, you can also use our plotting, like these plotting functionalities that we developed there. So that would be one interface, interesting interface for the future.
So I'm going to be presenting a bit of a rather similar stuff, maybe at a bit different level, where what we've been building in the Spine project, also open source. You can see the address there to the repository and then the manual. We are 3 years into a 4-year project. I think we can already do quite a lot with the system, but it's certainly not finished. And we are trying to add new stuff there all the time. But let's see what we actually have right now in terms of this. I'm going to try to show you how you could serve 2 different models from the same database. So here is the interface to Spine Toolbox, the workflow. You can build here different kinds of workflows. This is a very simple system, especially on the side of the getting data into the system. I have here a link to an Excel file, and I can import that with an editor where I can do these mappings. So if I, for instance, have a sheet in Excel where I have the demand time series, I can map them here using the specifications here. So on the y-axis, I have mapped the time, and then on the x-axis, there is the different nodes. And of course, these can be in any order, and you can remap them as needed, and you store these mappings, and then you can re-import if you need to get new data from the same Excel format. Another example is where the entities are power plants here, and they have multiple parameters on the x-axis, and then we can import all of those different parameters as parameters into the database I will show soon. And then the last example is where the data is actually structural data. There is no numbers. It's just showing the structure of the model, and that's of course always important also to include in the data system itself, so that you can serve the model also with structural data. So now we have the data here in the Spine database, which is SQL. It can be an SQLite, which is a file. It can be a server-based SQL. I'm gonna try to show a little bit of the things we can do here in the data side. I mean, you can of course always just use it and import Excel data, but sometimes you also want to work on the database itself to view it or even edit the data. So this is the data format. I'm not going into there, but it's using an entity attribute value system. It's a very flexible data format and doesn't really care what the data is, and it can contain like here we have just regular values, but we can also have maps like so you have the time indexes and then the values that were imported from the Excel. But these can also be nested maps, so we can have stochastic data and basically underneath there is a JSON that you can define as you need for your system. I can also filter this by choosing which kind of entities I show. Now I show only the nodes, or I can show only the power plants, or I can show everything. I can also filter using scenarios and alternative values. Here I have defined for the plant A an operating cost for 2 different alternatives for the same value, and I can use the filtering here as well to only show the base scenario values or the alternative values, and these can be then of course sent to the different tools. I can switch to different views, like a graph view. It's a very simple system, 2 nodes, 3 plants. There is no connection between the nodes, just to keep it simple for the example. I can also show it as a tabular data, so that I can take these different dimensions and put them into different axes, like you could do in GAMS, for instance, or I can then change the values and store the values when I exit and tell what I just did. All right. There was also, I didn't realize I should have shown this one as well, but we also have this system where we have a let me go back to here, and we have features and methods. So sometimes or often your models don't support the same things. Here is an example where the other model supports ramp constraints and the other one doesn't. So I can have here a ramp up method defined for the GAMS model, and then this system knows that it shouldn't be sending any ramp data to the Julia model, because the Julia model doesn't understand about the ramps, and therefore we are trying to build this in a way that when you're modeling, you need to be very explicit about your modeling choices, and you know what you have chosen, and you can see what you have chosen. It will also help with validation, so that you can't send so if you're missing a data, you want to do ramps, but you don't have ramp data for the plant, it can tell you that there is a missing data point there. Then the next step in this chain here in the Julia side is a script, which is pretty similar to what Sarah was showing about the mapping. It's also a mapping, but it's written now in Python, kind of manual coding. It's reading a definition file, how it should map from a CSV file, and then it just takes the data from the database and sends it to another database where now there's new names there. We are building an interface for this as well, a tool item that can help you to do renaming and other transformations, because often it's not enough just to rename. You might need to do calculations and so forth. Then we have a Julia model here. There is a very direct interface. You can get the data from the database directly into your Julia code, so you can use the same class names you have in your data in your code, and build your code using the system here. On the GDX side, it's a bit more complicated because you need to make the data into a GDX file that the GAMS reads, and then it outputs again a GDX file that's again read back to the system. So if I run the whole system, the data flows through, and we should end up having stuff here at the end. But you can see that there is a Julia console here. So when it gets to run the Julia model, it will be running in the console view, and then the GAMS, there is no GAMS console, but you can still see what's happening in the event log. We should have the result here anyway. It's now showing results from 2 different databases at once. We can see there is a difference in the objective function. There's something still wrong in the model code. Whoa, now it just updated something because it just ran it through. And then we can have a map results here as well, but probably you want to be taking this data to something like Pyam, and we would be very happy to also set up that interface with good visualization tools like Pyam. So I think what's not shown here, but it's pretty important, is that we are right now working on making all this parallel. So these different branches can be calculated in parallel, and when you have scenarios, they can be also parallelized, and also that you can send to a cloud computer to be computed. So there's actually a separation between the interface you see here and the engine that is actually running the execution part of the workflow. I think that would be all then. Thanks. And I should then give to Stefan.
Yes, please. And thank you very much, Juha. It's super interesting what you have built here over the last couple of years in the Spine project. Looks really sophisticated.
Okay, hi. So if you, I'm Shubhayu, and I will give you a brief overview of how we are approaching open science at Sentinel. So if you move on to slide number 2, so this is essentially our the context and the guiding principles that we are working with. So Sentinel is a very diverse group of researchers and modelers. So we have energy models, system models, economic models, and other social models as well. So bringing in such a diverse group means we have to support a very wide range of workflows. So keeping that in mind, and we have to, whatever we do, we have to keep that in mind. That is the central sort of people we want to serve. And the goals here is to facilitate more reuse of research, right? So whatever other models have done in the same field, or for example feeding off of other models. So for example energy model, whatever output or research output you get, you might want to use it in a system design model, and so on, and maybe feed that back to an economic model, so that you can learn from each other's work, right? Making that easier. And of course, as I mentioned, because the community is so diverse, we have to support a diverse group of workflows. And as we saw in the survey earlier, that majority of the community prefers Excel, right? So that we have to sort of keep in mind. So if you move on to slide number 3, so what is the approach then? So then our approach is a very data-centric approach, as in that is what to connect different models to feedback between different communities. What is central is the data, right? So then we want to make that a smoother experience. How do we do that? The approach is to have rich metadata that sort of provides the context for whatever model that is being shared. So things like keywords, or easy way to describe your research, say a machine readable form of metadata essentially, right? And an important consideration is also providing license information, so that you know exactly what are the terms of use. And then on top of that, the actual data part is it's focused around tabular data. So there it would be the data set that you want to share, say the model output, or whatever else, and the schema that describes that data set, right? So for example, here I have a typical scenario of a time series, right? But then our our approach here is to require a minimum schema, right? So for a time series, what would be the minimum requirement? Timestamp and a value. So this is a minimum requirement. But then if you move on to the next slide, you'll see that it is optional to add other values, right? So to conform to our data format, all you need to do is have the first 2 columns, and then anything else is optional. So if you need it, you can add things, but if you don't need it, you don't need to, right? And similarly, you can think of expressing all of your other data in a similar way. So then the idea is, for every commonly used data set, there is a minimal schema that you have to adhere to. But then for your own special purposes, maybe you are doing some new analysis that requires new data, you can keep on adding, make your data set richer without compromising your compatibility with other people in the community. So this is the essential approach. And how do we do that? If you move on to the next slide, slide 5, we have chosen to use the frictionless data format. This is a specification, it's an open specification. I think it's used by the OPST community, and it essentially is a it supports mostly tabular data sets and also some others, some geographic like GeoJSON, TopoJSON, that kind of stuff. Yeah, so now, so this frictionless data set, it is essentially this metadata plus data put together in one place. The metadata is in a JSON file and the data is in CSV or Excel files, right? And it also provides this and it also provides this UI where you can sort of uh, create this JSON file, make it easier. So we try to incorporate the tools that are already out there for this specification into our implementation of it, so that there are more options. So people who are comfortable with, say, running something like a script, they can run a script, but then people who would prefer to use a website or a GUI based workflow, they can use that too, right? That's the idea. So if you go to the final slide, slide 6, so this is all well and good. We can try to propose something and expect people to use it, but that doesn't how things go, right? You need to have a strategy for people to sort of incentivize to try your try your work, right? So our approach here is to first so provide all the technical stuff, technical requirements, the technical tools required for adoption, make it easy. So for example, ingesting different kinds of data and writing it out in this format. So tools for that, we are working on that, right? And the next strategy is to provide additional value. So a common requirement is validating your input data, right? Or making sure it's consistent. So we provide this kind of validation tools. This is a work in progress. And a stretch goal, which is a planned thing in the future, if it is going to be possible to, is to have a visualization framework on top of this. So that way, when you have a diverse set of models, you should be able to compare them, visualize, and maybe not only think of it in terms of a final result, but more of an intermediate tool set, right? So when you're working on your model, iterating on your model, you might want to look at, okay, how is it progressing? Maybe you want to look at intermediate product, intermediate output. So it's kind of like a debugging tool, visualization as a debugging tool. That is one of the sort of hopes. Okay, that's it. Thank you.
Thank you, Suvayo. Really interesting presentation. In the focus group, on behalf of the Open Entrance Consortium, I want to also present something that is similar but also different to what my co-panelists have presented so far about building scripted workflows to integrate models. Is similar to all the other projects here. What we want to do is develop some platform modeling tools for the European energy transition. And similar to what Suvayo has presented in the Sentinel project, we want to combine a large ensemble of models. So whereas Juha has more this integrated toolbox, we want to build something that a lot of different tools can easily tie into. And then the question is, how do you actually get your scenario results to other teams so that they can use that as input or can use that as validation? How do you get results from other teams, and how to disseminate your results at the end of your project or during your project to policymakers, stakeholders, and researchers? And what we are doing here, what we're using here is the EASA scenario infrastructure, scenario explorer infrastructure, which is similar but slightly different to what Sarah presented on this open energy platform. So the EASA scenario explorer will serve as a central data exchange hub, and then all the modeling teams can write their model results and input data to that central platform and get results from other teams to use as input in their own models, and then also use that as a dissemination portal to the outside world, to stakeholders, to policymakers. So what do you need to upload your results to this central data platform. And this now brings together 3 topics that were mentioned in different formats by my co-panelists. First, you need a common data format, and here we decided to base this on the IAMC format. From the poll at the beginning of the talk, some of you are already familiar with this. I put an example here. It's an intermediate solution between the very basic structure that Subayu has presented, which is completely generic, and then the other extreme is what Sarah presented, which is this very well-structured data model. The IMC template is something in between, so it assumes that there is some structure, like that there is a column named region, that there is a column named variable and unit. But the important thing here is that this is easily workable with in Excel. You don't need to touch SQL databases to work with that. And as we also seen from the poll, a lot of people feel comfortable working with Excel. And you need to have a data model, I think, that works in that realm and to that audience. The second part is an open nomenclature of definitions, regions, and how you name sectors. And again, Sarah presented something that is very well structured. So this open energy ontology, where you have a host of definitions. We tried a different approach, namely to have something that is much more bottom up. So we start with a small set of variables and then add this as a collaborative process on a GitHub repository. Also, the way how the data is structured is different from the open energy ontology, whereas they use some very sophisticated ontology tool that allows you to cross-reference, but it also is a bit of a hurdle to get started with understanding the ontology. We, in the Open Entrance project, started using YAML files, which are very simple text files, and there is an example here on the slide. YAML files are machine readable, so there is a structure imposed, but at the same time, it's also human readable. So you can just open these YAML files and do a Control F, like how do they name wind energy, or how do they name CCS? What is the definition of CCS? So you don't need to install a tool. You just can go to the GitHub repository and check out, well, how did in the Open Entrance project they name this particular variable or this particular region? And then the third part is the tools for automated workflows. Sarah already mentioned this PyM package that we have been developing at IASA as a community tool over the last couple of years. It provides a couple of nice features like aggregation, downscaling, unit conversion, validation, and then also a plotting library. All of these were mentioned by Subayu and Juha, that these are relevant tools and features that you need if you want to take your results from one model and put them into another model, because the regional specification may be different, the time resolution may be different, so you need some automated tools. And we have this Python package that does some of that. The important part here, and that's I think the big contrast to the Spine toolbox and also to the Open Energy platform, is that you can use all 3 of these tools, so the data format, the nomenclature, and this PyM package separately of each other. So it's not one integrated solution, but you can say, I don't care about the IMC template, I don't care about the nomenclature, but I want to do unit conversion, so I can use the PyM package for that. Or you can say, I want to work together with the Open Entrance modeling teams, but I don't want to use Python. So then you can just go to the GitHub repository with the nomenclature. You can look at how do they actually name their variables, how do they name their regions, and you can just extract that from the GitHub repository and then use it in an R workflow, or directly in GAMS or in Julia or whichever programming language you want to use. So it's more a subsidiary kind of infrastructure where you can pick and choose. That means it's less sophisticated than the other solutions, but the advantage is that the entry point is hopefully lower for modeling teams that are interested in using that. And with that, I say thank you for your attention. That was the 4 introductory talks from the 4 consortia and projects that are contributing to this focus group. I now want to invite you to go back to Slido to a final question, we have planned 2 breakout groups, one on this common data model for data exchange, which will be moderated by Suvayo and Sarah, and a second breakout group, which is on the workflows for passing data between models, tools, and platforms, which is moderated by Juha and myself. And the problem is that in each breakout group, for technical reasons, there can only be 25 people. But now we have more than 70 people attending this plenary or this focus group. So not everybody who is now listening can join one of the breakout groups. So we wanted to get an understanding of where people want to go, where they really want to go, or where maybe they are interested. So please let us know so that we can figure out how to do this. While you do this, I want to apologize that we can't have more breakout groups or can't have a larger breakout groups. There are technical restrictions, and we also thought that keeping the number of breakout groups small, so to have them on 2 focused topics, makes more sense rather than having them spread out where you have a lot of parallel discussions. Okay, so it seems that we're not going to run into the 25 people constraint, which is probably good for a productive discussion. To all those who don't want to join one of the breakout groups, please come back to this GoToWebinar room at 10:45, where we'll do a short reporting back session. And now please either leave or pause this GoToWebinar, go to the EMP-E Beat2Match tool, and there you have the links to these 2 breakout group sessions. And we'll see you there in a few minutes to have a bit more focused discussions, and then come back to the breakout groups come back to the plenary to this GoToWebinar room at 10:45. Hello everybody, welcome back to the plenary after our 2 breakout groups. Sarah is already here, still waiting for Juha, and I'm not sure if Suvayo can join via phone again. While Juha is connecting, Sarah, do you want to go ahead and give a summary of the first breakout group?
Sorry, can you hear me? I think I had some problem with the connection.
Yes, I can hear you.
Okay, so yeah, I can do that. So first of all, we set up a protocol for the session. So we collected all the questions and answers in the protocol, which I can share hopefully via the chat if there is. Okay. Yeah, so we were doing a Q&A session when talking about data models in general, and I just want to name a few problems that we see. So there was one. Yeah, so there's sometimes uncertainties what problems modelers or challenges modelers actually facing when it comes to data models. Then there's also a problem that we discussed briefly on the problem to find open data to build models, and that it would be very helpful that there is something like a list of databases or something where you really know where to find open data, and in formats like standardized formats also. And yeah, then we were talking a little bit if it's, or we were agreeing that we definitely cannot have just one data model because there are different needs, requirements. But that one way would be to, as a developer, you of data models or also these platforms, you always should keep the modularity in mind and really try to define easy plug and play to things that are already there. So to give it just like a kickstart starter that others also feel able to contribute, so that already some infrastructure for that is there. Yeah, then there was the question how scalable, for example, the ontologies are on the platform. So if you have a specific modeling case and you see that it's not covered in the ontologies on the platform, how can you contribute? Is interconnectivity between platforms given? Yeah, so there we are also, I think we also slightly went into the exchange discussion. So I'm interested in what you summarize now from your exchange workflow discussion. Thank you.
Thank you for the summary. Juha, can you give a short presentation of the other breakout group?
We were a little bit talking about that there is these available sets and how to utilize them, and also we tried to talk about some of the social aspects related to that, but I don't think we get very far with that. Then we started also discussing the data format and whether we are heading towards something that would be commonly shared, and also had a bit of discussion that what it would take that we actually get there, and maybe at least for me, the important thing is there that we just need to keep trying, and we need to be educating the new people coming into the field to be using the best practices, and also to try to work towards a common goal. And we know this is very hard because we have so many energy system models already out there, and we shouldn't end up in a situation where we also have a lot of different nomenclatures for those everybody's using a different one. Then on the other hand, then there is of course that there are quite a different needs when you look at all the different kinds of modeling that's taking place in the energy scope, and it might be a challenge in that sense as well. Then we discussed about the workflow as well, and so one comment was that people already have things working. They have set up systems that can get the data and get it to their models, get the data from many various sources, and get models to run and see the results, and so forth. So what are exactly these workflow tools bringing that would be additional and beneficial? And at least for me, the answer maybe is that there are people of different, that there are different kinds of users. Though there are those who are very familiar with coding and using these tools, and then there is modelers who are not so interested on the tool side of things. They just want a system that works and they can play with the data side and analyze future scenarios and so forth. I don't know, that was what I was able to put together. Maybe you have something additional.
That's a good summary of the second breakout group. If there are any urgent questions left, then you can use the GoToWebinar tool to shout now. If there are no questions left, then we are surprisingly finishing 1 minute ahead of time. I think it was a super interesting discussion. I want to thank the co-panelists from the 4 projects, Spine, Open Energy Platform, Sentinel, and myself for Open Entrance. I also want to thank Naomi, Saminda, and Sebastian for being available as support to make sure that this actually works. Because, well, as we saw in the beginning, we still haven't figured out 100% of the technicalities of operating conferences online. So thanks a lot to these three people for being available and helping. I think we made some good progress on at least identifying the questions that need to be answered, and within these 4 projects and then also other projects, work towards better integration for integrating models and answering the questions of how we can get to full decarbonization in Europe soon. Thank you very much to all, and I'll see you all, well, not see you, but I guess we'll all be there together in the closing plenary later today. Thank you very much.
Thank you. Thank you for the moderation also.